In this section, we're going to look at some of the basics of the JunOS CLI. First off, starting with how do we just revert the box back to its default initial configuration, which then we'll be using that as a baseline for going through some configuration examples. We'll talk about how the JunOS CLI modes work. What's the difference between what is effectively global configuration in JunOS and what is effectively exec mode in JunOS. We'll talk about the differences between the configuration structure. How does the active config versus the candidate config work, and how do the config commits and rollback work? We'll talk about how we can get help from the syntax point of view or from the CLI point of view. If you don't know how to do the syntax for a particular implementation, there's a number of different ways that you can get help directly from the CLI. We'll talk about the parser hierarchy and how this works a little bit differently than the iOS hierarchy. Talk about some of the common commands, and then finally talk about how do we manage the different configurations and their commits. So before we get into any of the details of the rest of the CLI, I'm first going to start by deleting the configuration of the boxes that I'm going to be using for our examples, and then we'll let them go through a reboot while we start to talk about the actual CLI structure. Now, in terms of Cisco iOS, the way that we revert the box to the default configuration is just by erasing the startup config and then basically reloading the box, either the router or the switch. Now, in JunOS, we're basically going to do the same thing. So we do require a reload in order to get back to the default config, but of course the syntax structure is going to be a little bit different. So the first thing that we do is to start the CLI process, which is just the command CLI. We'll talk a little bit about this later to see the specifics of it. We go to effectively what is global configuration. We load the default config, which is essentially the same as erasing the config. Configure a new root password, save the config, and then reboot the box. So let's take a look at this specifically on the CLI, where, as I mentioned, the first thing that we're going to do is to start the CLI process. We simply say CLI. We go to configuration mode. We say configure. We load the factory default config. We then need to, and if we were to try to save the config here, which is with the commit command, we'll see the next step that is required is that you do need to configure a root authentication password. Where in the case of Cisco iOS, by default, there is no password, even when you're connecting from the console. With Juniper, it always requires login authentication. So if you don't have any other users configured, then we have simply the root user. So we're going to set a password for them. We need to set the system root authentication password. And in this case, it's going to be a plain text string that we're going to enter. So enter whatever password you want twice. We'll save the config. We say commit. And depending on the physical box, this may take a couple minutes to go through the checks and actually save the config. Then we'll exit out of the configuration mode and then finally reload, which is request system reboot. Okay, now in the meantime, I'm also going to do this for the rest of the boxes. So once we start to go through our configuration examples, we know that we're starting from the same place, which is not necessarily a blank configuration, we'll see, but just the default factory configuration. So I'm going to go ahead and quickly do this on all the other boxes at the same time. That I'm going to enter the CLI, to go to global config, to load the factory default configs, to set the system root authentication password, and this is going to be a clear text password, actually plain text password. Okay, I'll give it the password. I'm going to say that this is Juniper with a 1 and a 3. Commit the config and quit. And then we'll request a system reboot. Okay, so now all of our boxes are going to come up with a default configuration. So first up to start, let's talk about what are the differences in the CLI modes. Now, in the terms of regular Cisco iOS, we generally have 3 different modes for accessing the CLI. We have the user mode that is generally for running read-only commands like show IP interface brief, show interfaces, show IP route. We then have exec mode, which is normally our privileged exec, which would be the router's hostname followed by a pound sign. This is where we can run additional verification commands, but generally they're going to be of a higher privilege level. For example, to look at the running config. And then finally, we have global configuration, which is where we're going to actually make our changes. Now, inside of global config, we also have the hierarchy of the rest of the configurations. We have global config, then we have interface subconfiguration, we have router subconfiguration. So we'll see as we compare iOS to JunOS, there is some hierarchy to both of them, to iOS and to JunOS, but generally JunOS has a stricter and a little bit cleaner hierarchy as we look at some of the final configurations. Now, as we compare this to JunOS, JunOS has a Unix shell, plus it has 2 main CLI modes as opposed to 3. Now, the shell, as we saw, is where we're first placed when we log into the box. So we log in as the root user. This is going to place us into the Unix shell that we can run normal Unix commands like listing the directory, changing the directory, ping, traceroute, netstat. So basically, underneath it is a Linux box. It's based on BSD code, I believe. So normal verifications of the system, you can do that from the Unix shell. Now, from our point of view, we're mainly going to be focusing on the CLI, not the Linux that's running underneath behind the scenes. So once we get into the shell, next thing that we're going to do is simply to issue the CLI command. This is going to start the command line interface. Now, as I mentioned, there's 2 different modes for accessing the CLI in Juniper. We have what's called the operational mode, and we have the configuration mode. Now, operational mode is the one that is denoted with a greater than sign, similar to what you would have in user mode for iOS. But this is equivalent to both user mode and privileged exec mode in iOS. So we can run read-only commands like look at the interfaces, look at what are the IP addresses assigned, but we can also look at the running configuration. So it's essentially going to be the equivalent of both of them at the same time. Then we have, in terms of commands that we would run at operational mode, mainly this is going to be where you are issuing the show command. So you're checking the device operation, looking at like the routing table, looking at BGP neighbors, looking at the overall configuration. There are a few things that you can change from here, like we saw that you can request the system to reload. You can write files to the file system. You could upgrade the OS. But mainly in general, operational mode is going to be for running read-only commands, similar to what you would have in either user mode or exec mode in terms of regular iOS. So if we take a look at our boxes, I believe probably the VSRXs should have reloaded by now. So this is going to be the default login prompt when we're coming up with a blank config. And you can see this keyword here, it says amnesiac, which basically means that there's no configuration applied. Now, depending on what is the particular version, what's the particular platform that you're logging into, some of them will have the root user with no password. Some of them will have the root user with the specific password that we previously defined. So in this case, I had already defined a password. So if we log in as root, and then the password that I defined, this should drop us off at the Unix shell. So if we print our working directory, we can see that we're in the root directory. We can list files here. We can do ping. We can do traceroute. So most of at least the core normal Linux or Unix commands would be available from the shell. But like I mentioned, from the shell, the main thing that we're going to then do is to start the command line interface. So we're going to say CLI. Now, once we get into the CLI, as we can see, this is denoted by the greater than sign. This is where mainly we're going to be running our different show commands. Now, we're going to spend a bunch of time talking about the parallels between the commands in JunOS and iOS. So once we go through the basic structure of how do you even use the commands to begin with, then we'll start to come back and talk about what's the equivalent of show IP interface brief, what's the equivalent of show IP route, and so on and so forth as we start to get deeper in the different technology domains. So if we think about some of the main commands that we're going to be running from operational mode, like I said, most of the time this is where you're going to be showing different options. You can also do tests here like doing a ping or doing a trace route, where just like in iOS, you normally cannot do a ping from global config. Same thing is going to be true from JunOS. Now, just like in Cisco where we have global configuration, JunOS simply calls this configuration mode. So this is where we're going to be making any changes. This is going to be denoted by the pound sign after the user and the host. So we can see as it stands now with our default login into the SRX boxes, there's not a host name defined, there's only a username, which is just simply root. So from here, if we were to say configure, we're going to go into essentially what's global configuration mode. Okay, this is the equivalent then of the router with the config in parentheses in iOS. Now, just like in iOS, configuration mode in JunOS is going to contain the rest of the hierarchy of all of the other options. So things that are global to the system, the specific protocols like RIP, OSPF, IS to IS, and then anything that would be at the interface level. For example, IP addresses, IPv6 addresses, trunking, link aggregation, and so on and so forth. Now, when we get into configuration mode, one of the key differences here we'll see between JunOS and iOS is that it always keeps track of where we are in the hierarchy, and it shows it here in brackets. So as we start and look at the configuration mode, it says that we are in edit. This is essentially the equivalent of global config in iOS. So if we were to look at this from an iOS box point of view, and let's say that we're talking about a regular router, normally we would start in user mode, which we can see is the greater than sign. We would then say enable in order to get to exec mode. So now we're in privileged exec. And we would say configure terminal or config T in order to get to global config. Now from here, when we actually want to make a change, let's say we want to go to the interface level and we want to change an IP address, we would issue the interface's name, for example, interface fastethernet 00, and then we would run whatever commands we want, like IP address, for example. But notice here in iOS, if we were to go to a different interface, for example, interface FA10, the prompt in the parser doesn't change. It's simply saying that we're under global config and that we're at an interface level, but it doesn't tell us what specific interface. And you'll see that this is one of the main advantages of just the parser itself in JunOS versus iOS, is that it always tells you where specifically you are in the hierarchy. Where a lot of the time in the Cisco world, you'll find that if you forget where you are, the only solution to that is basically to do Control-Z or end to get back all the way to exec mode, and then you could go back down the hierarchy to figure out where specifically was I configuring, what interface was I on, what routing protocol instance was I under, and so on and so forth. But we'll see in the case of JunOS, as we start to go down the hierarchy, it's always going to track it here under the field in configuration mode. So for example, if we were to go to the system, it says edit system. If we were to go to the interfaces, and then we were to go to our first Ethernet interface, we can see as we go down the hierarchy, which we're going to use the edit command for, it's basically going to track along the entire way so we know exactly where we are in the parser. Now we'll see the vast majority of commands that we're going to issue then are going to be in configuration mode. So when we're going to change an option, we're going to be using the set command, and we'll look at, there's a couple different ways that you can use the set command, either as a full expanse of the entire parser hierarchy from root, or you can use the edit command to go down levels in the hierarchy so that when you're setting a variable, you're going to do it based on your relative path in the hierarchy. So these particular commands, we'll come back to these later and talk about them in specific details. But the main point being is that configuration mode is read-write access. This is where you're going to be making your changes. Now, in terms of the actual configuration structure, we know in regular iOS, there's two different types of configs. We have the startup config and we have the running config. Startup config is going to be a backup of the configuration in NVRAM. Running config is the one that's in memory that's actually the current working configuration. Now, one of the disadvantages of iOS in terms of its configs is that when you make a change, it's immediately applied. So this means that if you issue a command in the wrong order, you have some potential ways that you can cause negative impacts to the network. So, for example, maybe you're live editing an ACL that's applied on an interface. You could accidentally deny your management session to the router or to the switch, and then lock you out from doing additional changes. One of the other issues is that when you make a change to the config, it doesn't automatically get saved. So you have to either write memory or copy run start in order to make those changes persistent. So one of the potential problems is you may make a bunch of changes to iOS, forget to write mem, and then for some reason the box reloads, then you're going to lose those particular changes. Now, in the case of JunOS, it's more similar to iOS XR in terms of its config structure, not similar to regular iOS. Or in other words, it essentially has two different configurations. It has the active config and it has the candidate config. Now, when we go from operational mode into configuration mode, essentially what we're doing is creating a new candidate config. This is going to be the changes that we make, for example, adding new IP addresses, adding routing protocol features, and then once we want to actually apply those changes, we're going to use the commit command to move them from the candidate config to the active configuration. So every time we make a change, we have to explicitly commit them with the commit command. So just like in iOS XR, there's some main advantages of doing this. One of them is that there's built-in error checking. That if you make some sort of logic problem in the syntax or some sort of syntax error, the box is going to tell you that before you actually go to make that change. For example, if you were to configure two different protocols that are not compatible, like you try to configure a regular spanning tree and a rapid spanning tree at the same time, it's going to say you can't actually do this because it's not compatible. There's going to be an error check with the config commit. The other advantage of this is that it always makes a backup of the changes that you make. So when a commit is successful, it automatically saves it to the commit database, which you could think of this like different subversions. So if I make a change and then an hour later there's a problem in the network, I can just roll back that change. I can undo it and see if the change was the cause of the issue. So in the case of regular iOS, you can do that, but it's really not as clean as it is in a regular, it's not as clean as it is in iOS XR or as it is in JunOS, because iOS wasn't originally built with that feature in mind. But both iOS XR and JunOS, as we'll see once we get into the CLI, they're going to do this by default. You always have to commit your changes if you want to actually apply them. The other thing that is similar between them is that we have both syntax completion and we have context-sensitive help. So this means that you don't need to type out the entire command. If you want to say show interfaces, you can say show int and hit either tab or space. Now, in iOS, normally you use tab for completion. In Juniper, you can use both tab and space. The difference between them is that tab is also going to complete user-defined variables. For example, firewall filters, which essentially are like access lists, or the routing policy things that are like the equivalent of like a route map in iOS, that if you define a variable name and you use a tab, then it's going to automatically complete it. Where in the case of iOS, it doesn't do that. You'd have to look at what was your ACL name or what was your route map name from the config, and then either type it in or paste it in, which is can be troublesome sometimes because a lot of that stuff is case sensitive, and if you don't type the variable exactly, then you're going to have some negative impact on the config. But in the case of JunOS, just like iOS XR, it does do auto completion of the variables that you manually define. We'll also see that it has a very detailed help system built in. Now, you can use it for context-sensitive help in terms of if you're in config mode, we could say set ? And this is going to tell me what are the different things that I can change. Or I can say show ? clear ? etc. So as you start to move through the parser hierarchy, just like in a regular iOS or just like in iOS XR, there is going to be the question mark for context-sensitive help. But beyond that, there's a bunch of built-in documentation to the OS itself that you can use as a reference for the syntax structure, so like a command reference, or a usage guideline to figure out how to actually use this command to begin with. Now, the first of which is the help apropos, which is basically a search to figure out what commands match this particular syntax. So for example, if we were to say help apropos route, this is going to show you all commands that have the keyword route somewhere in there. Now, some of them you'll see are the actual route command, like show route. Some of them have the keyword route as part of another piece of syntax. For example, like clear OSPF v3 database advertising router, because it's basically a regular expression match that you're searching for in the string. So there are some more advanced searches that you can do here. Like if I were to put this in quotations with a space after the keyword route, it would not then match anything that says route did, or for example, like we had before, which was the router. Okay, so that's going to show you just the general commands that you can use. The other one that's interesting is the help tip CLI. This just gives you random information about the CLI types of shortcuts, maybe that you didn't know how specifically they work. And that's going to be from config mode. If we say config and then help tip CLI, and you can just keep issuing this over and over and over, and it's just going to give you some random tips. Okay, some of them, I think I saw one of them before, said use the help tip CLI command to get help tips about the CLI. Okay, another one is help reference. Help reference, for example, OSPF area. This is basically the man page for the particular topic. So this shows you where specifically it is in the hierarchy. What's the structure of the syntax? So in this case, it would be the area identifier in the case of OSPF. And then what's the specific usage? So OSPF uses area 000 as the backbone, and so on and so forth. So assuming that you know what the syntax command is to begin with, you can use that as help reference and then figure out, what is the specific overall usage of this without having to go to the general documentation. And then the other one we have there is the help topic. And then you can go down into the hierarchy. So for example here, this one we'll see we're going to be using extensively. This is the address family identifier, or the protocol family. And it tells you what are the different options and then what are the usages for them. So we'll see, for example, in our case, the ones that we're mainly going to be focusing on are INET, which is for IPv4, INET 6, which is for IPv6, and then we'll also have ISO for ISIS. MPLS is going to be for label switching. And then we'll also have Ethernet switching, which is not on this particular platform, but Ethernet switching, as the name implies, it's going to be for layer 2 LAN switching. So things like trunking, access ports, the equivalent of like private VLANs, for example, that would be a function of the Ethernet switching family. Now, in terms of the hierarchy of the parser, iOS does have hierarchy like we talked about, but we'll see in JunOS the hierarchy is much more strict and it's much more clearly defined. For example, in the case of iOS, if you wanted to define an IP address on the interface, you go to global config, you go to the interface level, and then you issue the IP address command. The same would be true if you wanted to issue an IPv6 address or you wanted to configure an ACL on the interface. Basically, everything is going to be grouped under that last tree of the hierarchy, which is the interface level. But in the case of JunOS, the hierarchy is much more detailed, where we would go to configuration mode, go to the interface, go to the specific unit, which we'll see is basically the equivalent of a subinterface, go to the address family, and then specify the particular options under there. Now, the end result of this we'll see is that when we look at a final end resulting config in JunOS, it's easy to quickly see what options belong to IPv4, which options belong to IPv6, which options belong to OSPF routing, because they're going to be in their separate sections of the parser hierarchy. Now, when you're looking at the config, and when you don't know exactly how the syntax structure for JunOS works, it does look a little bit intimidating. For example, if we were to just say show from config mode, This is essentially the equivalent of show run. And it looks like the hierarchy is very, very in-depth and very detailed. But you'll see once we actually use the commands to change these different options, for example, like under root authentication, this is under system. Then under system, it's under root authentication. Then we have whatever the final variable is, encrypted password. So the way that you would read this is that anything that starts with a semicolon is the final leaf node. So it means that there's no other child values beyond this particular syntax option. For example, like an IP address, you would configure the INET address and then hit enter. There's no other options after that. If you see that it closes the curly braces, it means that there are other options beyond that. So in terms of root authentication, it means there's other options that you could do besides just doing encrypted password. Or in the terms of services, the services include SSH, but then under web management, there's other options under this. For example, there would be HTTP, there would be HTTPS, and so on. So we'll see once we start to get into more details of the config structure, you'll see that the final result is actually a little bit easier to read than it is in iOS, because with regular iOS, a lot of commands get jumbled together under either the global routing process or under the interface level. And if you don't know exactly what relates to one protocol versus another, it can be kind of confusing once the configuration starts to get very large. Now, in terms of navigating through the hierarchy, like I mentioned, one of the nice features of JunOS is that it always tells you where in the parser you are. So in this case, we're under global config or configuration mode. We're at the interface level, this specific interface, the sub interface, unit 0. Then the address family is Ethernet switching, and we're at the VLAN number. So basically, this would be the equivalent in iOS of saying something like interface gig 0, and then encap .1q, and then whatever the VLAN is, like .1q10. Okay, so maybe we're going to make a VLAN subinterface there. But the point being is that when you make the change, if you go up or down in the hierarchy, you know exactly where you are. You don't have to exit all the way to the top or the root of the hierarchy in order to figure out how do you get back down through the syntax structure. Now, in order to move down, we're going to use the edit command. In order to move up, we're going to use either the up command or the top command. So edit is going to move you down one or more levels. So here we say edit protocols OSPF. We could also do this by saying, instead of all at once, we could say edit protocols, edit OSPF. Or, for example, if we were to edit interfaces, we could edit our first interface, edit the subinterface like unit 0, edit the address family, which would be family INET, and then we can make whatever changes we want, like set an address, for example. So you'll see that there's multiple ways to accomplish the same goal in JunOS, where as opposed to going all these multiple levels down the hierarchy, you can do this all at once. So if I wanted to configure an IP address, instead of doing all those edits, I could simply say set interfaces gig E000, unit 0, family INET, address, and then whatever the particular value I want, like 1234 /24. And when we look at the question mark, you can see it says you can hit enter in order to apply the command. So basically, that's the leaf node. This would be the equivalent of going to edit interfaces, edit gig E000, edit unit 0, edit family, and so on and so forth. So there's multiple ways that you can navigate the hierarchy. But the point is you can always tell where you are just based on the output inside those brackets. Now, when you want to go up levels of hierarchy, so let's say we are at family INET, actually we'll say edit. And let's say we want to go up, but we want to go to gig E000. We don't want to go all the way back to the root. So we could say, for example, up 3. That's going to go up 3 levels where family INET was 1 level, unit 0 was another level, and then gig E000, that was the third. Likewise, if we were to go down, we could say edit gig E000, and then the rest of the syntax, that's going to bring us back to the leaf node. If we were to say up to, that's going to go to gig E000. The other option is if you want to go all the way up to the root of the hierarchy, you say top. This is the equivalent of either saying end in iOS or Control Z. Now, once you go back to the top of the hierarchy, it doesn't necessarily mean that we've saved our changes, though. So we'll still have to use a commit command to actually apply whatever configs that we want from the candidate configuration to the active configuration. And we'll see shortly how can we actually tell what are those changes that we want to use or want to apply. The other real useful feature of this top command is that you can run commands at the root level while already being in lower levels of the hierarchy. So for example, let's say that I want to see what's the configuration of the OSPF process, but I'm at the interface level. So let's say we were to say set protocols OSPF area 0 interface gigi 000 unit 0, which is actually, let's say edit protocols OSPF edit area interface. And then let's say we want to look at something under the configuration of an interface. So if we were to say show interface gig E000, when you issue the command, it's always relative to where you are in the hierarchy. For example, in OSPF or in iOS, if we were to say do show run interface, it doesn't matter where you are in the hierarchy. It's always going to run that from as if you were in exec mode. So kind of similar in JunOS, you can say top and then the command. So instead of show interface type, which is a match here under the OSPF process, I could say top show interface. And then this is basically the equivalent of do show run interface gig 0.